You ready to go? The Committee on Science, Space, and Technology will come to order. Welcome to today's hearing, which is entitled Threats from Space Part 2, a review of private sector efforts to track and mitigate asteroids and meteors. I'll recognize myself an opening statement and then the ranking member. A few weeks ago, our committee held a hearing to review U.S. government efforts to track incoming asteroids and meteors. Today, we will follow up by focusing on non-governmental efforts. The substantial public interest in this issue indicates the broad fascination with this subject. As witnesses said in our previous hearing, the events of February 15th, when an asteroid passed close by the Earth and a meteor struck Russia, were unique in their occurring on the same day. And I'm going to hold up a piece of the asteroid that exploded above Russia on February 15th. Maybe I ought to take it out of the bag here. And I'm assuming this is not toxic, is that right? Okay. But there it is, a nice size bit of meteorite there, a gift from the Russians. It was given to us by the principal investigator of NASA's asteroid sample return mission, which is slated to launch in 2016. In our first hearing, testimony about the government's efforts were not reassuring. Most troubling to me was the fact that of the up to 20,000 asteroids that could be labeled as city destroyers, we have identified only 10%. And we are unlikely to have the means to detect 90% until 2030. Detecting asteroids should not be the primary mission of NASA. No doubt the private sector will play an important role as well. We must better recognize what the private sector can do to aid our efforts to protect the world. Today's hearing will help us understand the level of risk as well as what capabilities we have and those we will need. The President's fiscal year 14 budget proposal brings necessary attention to this issue in general, but a consensus will have to be reached within Congress before progress can actually be made. This won't be an effort for one agency, one company, or one country. And in these fiscally challenging times, we can't afford duplication or the inefficient use of our resources. The more we discuss and understand the challenges we face, the easier it will be to facilitate possible solutions. Now I'll recognize the ranking member, the gentlewoman from Texas, Ms. Johnson, for her comments.
Good afternoon. I want to join the chairman in welcoming our witnesses to today's hearing. You each have deep experience and expertise directly related to the hearing topic, and I look forward to your testimony. As the chairman has indicated, this hearing is the second that the committee has held in the opening months of the 113th Congress on the topic of asteroids. Last month's meteor over Russia and the close passage of the near-Earth asteroid have both stimulated public interest in the potential threat posed by asteroids and comets. And this second hearing is certainly a reflection of that interest. I will not attempt to repeat the sentiments I expressed at our first hearing on this topic, and instead will confine myself to a few brief comments. First, it is clear that from last month's hearing, there is still a lot of work to be done to track and characterize asteroids that could potentially impact the Earth, and that even relatively small asteroids could be significant damage if they hit in a heavily populated area. So I hope that our witnesses today will help us better understand what will be needed to complete the existing survey, as well as perhaps extend it to a smaller size asteroid. Second, I want to better understand both the strengths and limits of NASA relying on private organizations, such as the B612, for detection of potential Earth impact in asteroids. My problem is not with the efforts of such organizations to address what they see as an important problem. Instead, my concern is that we have reached a point where our government has to hope that non-governmental organizations will somehow do what the government should be doing, but it apparently is unwilling to pay for it. However, if the protection of the planet is not an appropriate role for the federal government, I am not sure what is. And finally, before I close, I will note that the President's just released budget proposes to invest in a number of asteroid-related initiatives. We will need to closely examine the President's proposals in the coming weeks to fully understand what is being proposed. So I'm not going to comment on them in any depth today. Instead, I will simply say that I deeply hope that whatever new initiatives are being proposed will be accompanied by adequate funding of their own rather than be funded by cannibalizing other important NASA programs. Robbing Peter to pay Paul will not give us sustainable and effective NASA programs, and I hope we will all resist the temptation to do so as we try to address the challenges posed by near-Earth asteroids. Thank you, and I yield back.
Thank you, Ms. Johnson. Other member statements will be made a part of the record, and I'll introduce our witnesses now. Our first witness is Dr. Ed Liu. Dr. Liu is the CEO of the B612 Foundation, which aims to build, launch, and operate the Sentinel Space Telescope to help find and track threatening asteroids. He is a former NASA astronaut who flew 3 space missions and spent 6 months aboard the International Space Station. From 2007 to 2010, he led the Advanced Projects Group at Google. His teams developed imaging technology for Google Earth Maps, Google Street View, and energy information products, including Google Power Meter. He is also the co-inventor of the Gravity Tractor, a spacecraft able to controllably alter the orbit of an asteroid. And he has published scientific articles on high-energy astrophysics, solar physics, plasma physics, cosmology, and statistical physics. He holds a bachelor's degree in electrical engineering from Cornell and a PhD in astrophysics from Stanford University. Our second witness is Dr. Donald Yeomans. Dr. Yeomans is a senior research scientist, supervisor for the Solar System Dynamics Group, and manager of NASA's Near-Earth Object Program Office at Jet Propulsion Laboratory in Pasadena, California. His research focuses on the physical and dynamical modeling of comets and asteroids. He was a radio science team chief for the Near-Earth Asteroid Rendezvous mission. He has received 15 NASA Achievement Awards, and asteroid 2956 was named 2956 Yeomans in honor of his professional achievements. Dr. Yeomans received his Bachelor of Arts degree from Middlebury College and his PhD in astronomy from the University of Maryland. Our final witness is Dr. Michael Ahern. Dr. Ahern is a professor in the astronomy department at the University of Maryland. He is the principal investigator for the Deep Impact mission in NASA's Discovery program and for the Small Bodies node of NASA's Planetary Data System. His research emphasizes the study of comets and asteroids. Dr. Ahern received a Bachelor of Arts degree in Science from Boston College and a PhD in astronomy from the University of Wisconsin-Madison. We welcome you all. Thank you for being here, and Dr. Liu will begin with you.
Thank you, members of the committee, and thank you, Chairman Smith, especially for your leadership on this issue. So my name is Ed Liu, and I'm the CEO of the B612 Foundation. I want to thank you for the opportunity to testify before the committee to describe the B612 Foundation and its Sentinel Space Telescope project and the importance of that project. The B612 Foundation is a Silicon Valley-based nonprofit that is building, launching, and operating the Sentinel Space Telescope, which will find and track threatening asteroids. So NASA, at the direction of Congress, has found and tracked 95% of the large asteroids, those larger than a kilometer, that would likely end civilization were they to hit it. And so they've done a great job on that. And none of these civilization enders is known, thus far discovered, is known to be on an impact course anytime in this upcoming century. So that's the good news. But NASA has not even come close to finding and tracking the 1 million smaller asteroids that might only just wipe out a city or perhaps collapse the world economy if they hit in the wrong place. I would like to clarify something, and so I thought this image might be of help. I just show here a football stadium, which I understand now is Heinz Field in Pittsburgh. And we show a couple of asteroids there, just for scale. A 140-meter asteroid is not shown here, but it would roughly fit inside that stadium. And that is the size, that would, when they hit, that would release about 100 megatons of energy, which is roughly 5 times all the munitions used in World War II. Okay, so that is much larger than a city killer. That is a regional killer. Okay, and NASA discovered and observed and tracked less than 10% of the asteroids in that size range, sort of the stadium-sized ones. A 40-meter asteroid, which is the larger of these two, is what you would really call a city killer. The last one to hit was in 1908 in Tunguska, and that had an impact energy of about 3 to 5 megatons of energy. It destroyed about 1,000 square miles of Siberian forest. And we have observed and tracked well less than 1% of the million or so asteroids of that size. So if you ask how many city killers are out there have we found and are tracked, less than 1% is the answer. And there is about a 30% chance that there will be another impact of a city killer sometime this century, somewhere on the surface of the Earth. Just for reference, the smaller one shown there is about the size of the one that struck Chelyabinsk last month. So we simply don't know when the next catastrophic asteroid impact is going to be because we simply haven't yet tracked the great majority of asteroids. Again, less than 1% of these city killers have been tracked. Yet we have the technology to deflect asteroids, and Dr. Hearn will probably talk a little bit about deep impact, which was an experiment to actually hit an asteroid with a small spacecraft, and that's all you really need to do in most cases if you find the asteroids well in advance. And because you can't deflect an asteroid that you haven't yet tracked. Our technology is useless against something we haven't found. So that's why our number one priority from the standpoint of planetary defense is to find and track asteroids as soon as practical. You can't deflect an asteroid you haven't yet found, or for that matter, you can't capture it, you can't visit it, you can't mine it, you can't explore it until you've found it. So finding and tracking the roughly 1 million or so city killer asteroids in a reasonable time frame requires a system that can find tens to hundreds of thousands of them per year. Right? If you're going to get to 1 million, you need to find them at a very high rate. Anything less than that, from a planetary defense standpoint, is just playing around the edges. So this task of finding those smaller asteroids cannot be done even by large ground-based telescopes, optical telescopes, and especially cannot be done by small telescopes. And that's because asteroids are not only small, but they're dark. Their color is often as dark as charcoal, and that makes them really dim. So these smaller asteroids are only spotted currently when they come very, very close to the Earth. And so because most of the large asteroids have been found, unfortunately that means that amateur astronomers and people with smaller telescopes can no longer substantially contribute to this particular effort. Nor will small space-based optical telescopes, such as have been proposed by some commercial companies. They will not make a dent in this problem. But the fact that asteroids are dark can be used to our advantage because when they're small and dark, they absorb light from the sun and they're warmed. And that means they're brighter than the background sky if you observe them in infrared. And when you observe them in infrared, you can see them at much greater distances than you can with optical telescopes. So as described in the National Academy's report, Defending Planet Earth, if you want to find a substantial fraction of city killer asteroids, you need a space-based infrared telescope. So that's what the B612 Foundation is doing. Our Sentinel Space Telescope is going to launch in 2018. It will orbit the Sun about 30 million miles closer to the Sun than the Earth in a solar orbit, which is similar to the orbit of Venus. And that means Sentinel will not have a blind spot because, like Earth-based telescopes, which can only look at night looking away from the Sun. Sentinel will always look away from the Sun looking outwards at Earth's orbit. So it will find and track as many asteroids have been discovered by all other telescopes combined just in the first month of operation. Over 6.5 years, it will find over 500,000 asteroids, including more than 90% of the sort of stadium-sized ones, the regional killers, and the majority of those that are just city killers, the larger of these two asteroids. These asteroids will be tracked accurately enough to know if any of them is going to be on a course to hit Earth this century. So to carry out this mission, the B612 Foundation has assembled perhaps the finest technical team I've had the privilege of working with in my nearly 2 decades of involvement in aerospace, including 12 years as a NASA astronaut. The fact that we were able to recruit such a team is, I think, a testament to the inspiring and urgent nature of this mission. As we tell these people, who wouldn't want to have a chance to save the world? And that's really what I think drew them to the mission. So our major partner for transmitting our data back, as well as allowing some NASA experts to sit on some of our technical review panels, including, for instance, Dr. Yeomans here. The data generated by Sentinel will not only protect the people of the planet Earth, but will form the basis of future exploration and scientific missions. So a unique aspect of B612 is that we're carrying out this mission as a nonprofit. We do not receive any government financial support, and we are relying upon donations from individuals and foundations. These donors understand the importance of cataloging the environment we inhabit in the solar system, and they as individuals are making Sentinel happen because they know that our future may depend upon it. So make no mistake, raising this amount of money philanthropically with no expectation of financial return from our donors is challenging. But being a nonprofit has forced us to be very focused, and I believe it's made us resourceful. Our progress has been swift, and we are approaching now the second of our 8 milestones leading up to launch. The B612 Foundation is managing this project in an innovative Silicon Valley fashion with the rigor of a NASA project. So we are able to carry out this mission at what we believe to be about 60% of the cost is if it had been procured via federal procurement. So I should point out that the core technologies that Sentinel uses that allow it to detect dark objects via their infrared emissions would be useful to a number of federal agencies, including NASA. And there may be an opportunity to expand our existing public-private partnership with NASA in a manner that leverages our private donations, accelerates our technical progress, and in the end provides the data that could protect us all. Okay. So we can protect the Earth from asteroid impacts, but we can't do it if we don't know where those asteroids are. And that's why the Sentinel telescope is so important. Okay. I can't think of a more inspiring mission.
You're at 9 minutes and we need to move on. Are you? Okay. Can you conclude?
That was my conclusion.
Okay, good timing. Dr. Yeomans.
Mr. Chairman and members of the committee, thank you for the opportunity to discuss some issues related to near-Earth objects, and thank you all for your continuing interest in this topic. As noted by the chairman, back on February 15th, Friday, we had a 40-meter-sized object that passed within 17,200 miles of the Earth's surface and passed 5,000 miles within the geosynchronous ring of communication satellites that were announcing its arrival. 16 hours earlier, on the same day, we had an impact over Chelyabinsk, Russia, of a 18-meter-sized object coming in at 42,000 miles per hour, weighing 11,000 tons. And although I've been upstaged by Chairman Smith, I also have a piece of the rock that you may want to look at after the hearing. My point is that the close approach was a 1 in 40-year event for an object of this size getting that close. The impact of the smaller object over Chelyabinsk is a 1 in 100-year event. So very unlikely events do happen, sometimes on the same day within 16 hours. So large asteroid impacts with the Earth are extremely unlikely, but they could cause global problems. But if we discover them early enough, we have the technology to deflect them. Significant progress has been made to discover and understand the physical characteristics of near-Earth asteroids, largely as a result of NASA-supported efforts. For example, as pointed out, over 90% of those near-Earth asteroids larger than a kilometer have been found, and we've integrated their motions for 100 years, and none of them represent a threat. About 25% of the 140-meter-sized objects have already been found, and likewise, they do not represent a threat. So the goal is to find and track 90% of the 140 and larger sized objects, and in so doing, we will reduce the threat of all objects of all sizes to the 99% level. 1,000 new near-Earth asteroids are discovered each year, 98% of them as a result of NASA-supported surveys. 27,000 new asteroid observations per day are added to the archives at the Minor Planet Center in Cambridge, Massachusetts. And there is an increasing pace with which observations of near-Earth asteroid physical characteristics are being taken, including optical measurements, near-infrared measurements, and radar measurements. The vast majority of near-Earth asteroid discoveries are currently being made by the Catalina Sky Survey near Tucson, Arizona, the Pan-STARRS survey in Hawaii, and the Linear program near Socorro, New Mexico. And these surveys are continuously improving their discovery efficiencies, and the next generation of near-Earth asteroid survey telescopes and cameras are under development. However, as pointed out by Ed, still undiscovered are 50 to 100 of the largest near-Earth asteroids and several thousand near-Earth asteroids larger than 140 meters. In fact, there was a new 2-kilometer sized asteroid that was announced today. So we still have a handful of large ones to find and several thousand of the smaller 140 meter and larger. A dramatic increase in near-Earth asteroid discovery efficiencies is achievable using space-based infrared telescopes, either in a Venus-like orbit, as pointed out by Ed, or located about 1 million miles on the sunward side of the Earth at the so-called L1 point. The goal is to find the large near-Earth asteroids early enough to mount a deflection mission. The easiest and fastest deflection technique involves impacting a spacecraft on the asteroid with a rendezvous spacecraft there to monitor the success and verify that the object was moved just enough so that in 10 or 20 years, when it was predicted to hit the Earth, it would miss by a wide margin. What about the undiscovered millions of small near-Earth asteroids larger than 30 meters that are most likely to hit the Earth? The city killers, as Ed pointed out. Finding most of these near-Earth asteroids would be extremely challenging, and perhaps a cost-benefit study could establish the appropriate threat levels where it would make more sense to simply warn of an asteroid impact rather than finding it early enough to mount a deflection campaign. And NASA is currently supporting a program called ATLAS at the University of Hawaii that is designed to find objects a few days or a few weeks, small objects, a few days or a few weeks prior to impact. And the object there, of course, is civil defense. If you find it several days in advance, you could evacuate if the object was threatening a populated area. So in summary, with the current near-Earth asteroid threat identification process in place and suitable augmentations to NASA's near-Earth object observation program, we can determine which near-Earth objects represent potential future threats and do so with enough time to either deflect the larger objects or warn of the arrival of the smaller ones. Thank you for your attention.
Thank you, Dr. Yeomans. I was also going to mention the book you wrote that just came out this year called Near-Earth Objects, Finding Them Before They Find Us. That's a nice subtitle, but appreciate your writing about this subject and who knows, maybe anticipating the publicity that the subject would have this year as well. Thank you for your testimony, Dr. Ahern.
Mr. Chairman, members of the committee, thank you for the invitation to appear today and to discuss a variety of aspects of the near-Earth object hazard. I'll talk a little bit less about finding them than Don and Ed have done, and more about what to do about it. Once we complete the George E. Brown survey down to 140 meters, we have taken care of a large fraction of the risk where we can get long advance warning and therefore have plenty of time to mount a mitigation campaign. As was just pointed out regarding the ATLAS survey, that's designed for late discoveries. And as we go to really small ones, late discoveries will be a different kind of issue because then we don't have time to do mitigation other than evacuation. For a 30 to 50 meter city killer, and that's really more than a city. Tunguska was 2,000 square kilometers. You can, in principle, do evacuation. But if you get much larger than that, 75 meters, 100 meters, evacuation is no longer practical, and you need to have a plan in place with tested technologies to try to do mitigation on relatively short notice, because these are likely to be shorter notice than the ones we've been discovering so far, where we've been aiming for years of advance warning and plenty of time to plan how to mitigate. The mitigation is a key part of the hazard issue, and when the National Research Council issued its report, it suggested programs at a variety of different levels. depending on how much insurance you wanted to buy, basically. And if you really want to include mitigation as part of that, it's up at the couple of $100 million a year level in order to include mitigation as part of that. Now, it's interesting that much of what we know about mitigation so far has come from research programs. They're the ones that provide the physical characteristics. Earth-based remote sensing tells us about the sizes of the different asteroids, tells us about their surface composition, not necessarily their interior. For a few of them, like binaries, we can get interior bulk densities. But missions to these objects, we just heard a mention earlier from the chairman of the sample return mission that will be launched in 2016. That mission will tell us a great deal about the structure of an asteroid, the internal structure, and what the materials are, and therefore what kind of techniques will work efficiently for mitigation. The Deep Impact mission, of which I was the principal investigator in 2005, carried out an impact on the nucleus of Comet Tempel 1. It showed, first, that cometary nuclei are remarkably porous. That makes them harder to push around than, say, a solid iron asteroid. And the rocky asteroids, which are fragmented, are somewhere in between. It demonstrated new techniques for autonomous navigation to lead to an impact, whether you are doing a kinetic impact or a standoff nuclear explosion. It demonstrated how difficult the attitude control is when you get close to some of these. Milligram pieces of dirt or rock were bouncing our third of a ton spacecraft around by many degrees, causing serious pointing problems. That's an important thing you need to do if you're developing mitigation. So these research programs are important because they're the only ones that are now providing us information on physical characteristics. Unfortunately, the Discovery program has been devastated. It was originally conceived as roughly a mission every 2 years. In the 1990s, there were 6. In the 2000s, there were 5, the last of which was in 2007. Then there was a 5-year gap until the one that was selected in 2012, namely InSight, the mission to Mars. And with NASA's current plans, the announcement of opportunity for the next one won't be till 2015, which means selection to fly in 2017. So we're down to 2 a decade instead of the 5 a decade that the decadal survey recommended and which was the basis for the original program. Frequent opportunities to go to space are critical. Also, just as it's important to partner with the private sector, it's crucial to also partner internationally for mitigation, because mitigation can be seen as threatening. And we need to develop real mechanisms. We've talked a lot with potential international partners. We need to be talking to people who aren't our partners, such as the Chinese, people who might think something we did in space was a threat rather than trying to help. And that needs to be something that we look very carefully at in the near future. Thank you.
Thank you, Dr. Ahern. I'll recognize myself for questions. Dr. Liu, given the fact that we do have budget constraints and that funding is limited, what's the single most important thing we could do in, say, the next 3 to 5 year time period to detect these threatening asteroids?
Well, if you're going to ask what's going to find the most number of these asteroids that of anything that's currently planned, I think it's Sentinel. By a pretty good margin, and if you were to ask, to get to what Congressman Johnson mentioned, which is, we are a private organization. Mm-hmm. There are opportunities to accelerate our development. We could, in principle, deepen our relationship with our currently existing public-private partnership if we wanted to accelerate that. We understand, again, that the technology that we're developing, the core technologies are useful for lots of other things that the federal government finds important. And so, one of the possibilities is to accelerate the technology development. Another possibility is if this data is worthwhile to NASA, if it's important to NASA, perhaps we could work out something where this data is purchased from us. In that way, NASA only pays for it if the data is good, and they can work with us to make sure that as they already are, that the quality of the data is what they need.
Okay. Thank you, Dr. Liu. Dr. Yeomans, I'm sure there's an answer to this that I should know, but we've always been told that in the case of near-Earth objects, the only alternative is to move them out of their orbit or deflect their trajectory so that there's no direct impact, and it doesn't do any good to explode those objects because then we just get a shower of near-Earth objects, many more, but they're smaller. Wouldn't it be possible to explode an incoming asteroid with such force that the pieces would be so small that they would burn up coming into the Earth's atmosphere? So is that a realistic alternative or not?
Yes, it is, actually. There's been some work done by Dave Dearborn at Lawrence Livermore Laboratory suggesting that computer simulations, if you insert an explosive charge and detonate it, you often get the fragments going off in such a velocity and direction that what little does hit the Earth does very little damage.
Why is so much, therefore, so much time, so much effort, so much focus on moving it out of its current trajectory? Why not more focus on what you just described?
Well, it's actually considerably easier to run into it and slow it down a tiny little bit than to land on it and plant an explosive device.
Maybe a practical answer as well.
Technologically easier.
Okay. Dr. Hearn, you mentioned about the time that we would have or not have if we detected an incoming object and had to deflect it. What would be the average time that we would have, say, of a city killer-sized asteroid? I guess it depends on whether you're using ground-based telescopes or space-based telescopes. But say in the next 3 to 5 years, how much time would we have if we developed the Sentinel program and were able to detect these objects?
I will defer questions on the sensitivity of Sentinel to Ed Liu.
Okay.
But in general, it's important to remember we've only ever detected one incoming object before it hit.
We have a long way.
That was less than a day out.
Okay. Dr. Liu.
And that was very small.
Do you have any ideas on how much?
The goal for Sentinel is to find things decades before they hit, so that you can deflect them rather than evacuate.
You have plenty of time. At our first hearing, Dr. Holdren made the point, I think, that only 2% of the Earth's surface consists of urban areas, and so that further diminishes the possibility of, say, a city sustaining a direct hit. I'm not sure that's much consolation to those who live in rural areas, by the way, but at least it was interesting as far as the amount of damage that might occur. Okay, thank you all. You've answered my questions, and the gentlewoman from Texas, the ranking member, Ms. Johnson, is recognized for hers.
Thank you very much. Dr. Liu, I realize that details over NASA's proposal in its fiscal year 2014 budget request to conduct a mission to an asteroid with humans and other asteroid-related activities are just trickling out. A story over the weekend reported concerns about the asteroid initiative from 2 sources. One worried that NASA's activities may interfere with the private sector efforts. Another was critical of the absence of international collaboration. Based on what you have read or know of NASA's plans, are such concerns warranted?
I don't think so. I believe that I, as much as anybody, want our human spaceflight program to have a clear, defined, and inspiring goal. However, I don't think this mission should not be confused with one that is planetary defense. That is it is a different mission. Mm-hmm. What that proposed mission is to do.
Dr. Yeoman, can you share details on NASA's asteroid detection efforts or efforts that are scheduled to benefit from a funding increase for the coming fiscal year?
Yeah, it's my understanding that the asteroid retrieval mission is primarily a technology test of the solar electric propulsion system. It's also a rendezvous with an asteroid and bringing an asteroid back into a lunar orbit. So it has components for NASA's technology program, the human exploration program, and of course the most challenging first part of this whole mission idea is to find a suitable target. And so the plus up that you mentioned in the budget will certainly provide a commensurate increase in the number of objects that are discovered and could be utilized for space resources, scientific investigation, planetary defense, as well as a target for this mission.
Dr. Ahorn, did you have any comment?
No, I have no further comments.
Okay. Thank you. Now, in the first round of hearings that we had, there was mentioned an orbiting telescope, which we don't have access to. Could either of you comment on the value of having an orbiting telescope?
Well, the
detection?
the Sentinel is an orbiting telescope.
It is.
But it does not orbit the Earth, it orbits the Sun. But it is a space telescope.
There is also,
Yes.
there's also a concept where you have a spacecraft a million miles sunward of the Earth, also orbiting the Sun, but it's closer to Earth and could be looking out toward near-Earth asteroids as well.
So, in view of the seemingly increased interest or activity of the asteroids, how do you see an investment in an orbiting telescope that would orbit the Sun, or any place that's not orbiting now? You see any value in?
Oh yes, yes. As mentioned, the benefit of having a telescope in space is severalfold. First of all, you can use an infrared detection system. These objects are much brighter in the infrared and much more easy to find than in the optical. You don't have problems with weather or day and night. You can observe these objects from a viewpoint that the Earth cannot, so you sometimes get a advance warning in that respects, and so it's a far more efficient system from space.
Any other comment? Okay. Thank you, Mr. Chairman.
Thank you, Ms. Johnson. The gentleman from Texas, Mr. Hall, the Chairman Emeritus, is recognized for his questions.
Mr. Chairman, thank you. I probably ought to just write a book on this, my questions, because I have so many. And this is your second hearing, is that right? That's correct. And I admire you for it. You're almost seeking something that's impossible. From the numbers even that I've heard here. Olin Tiger Teague, whose picture is right over there, ought to be known as the father of NASA. And you might even become the father of characterizing Earth objects and how close they are. But I think you're going to have some overseas hearings. We've had this second one, and 4 more just like this probably won't give us any definite answers. But it's a very interesting matter, very interesting item. But how could we ask, maybe Dr. Yeomans on the Near-Earth Objects program, like in 2013, worldwide attention in the city of Chelyabinsk in Russia injured a lot of people but didn't kill anyone, is what I understand. And others that I remember and that we've heard about, a lot of injuries, but they didn't know it was coming and didn't know when we had that hearing, and I think I testified to this before, we found out in that hearing that one had passed Earth and just missed us 15 minutes, and that could be a jillion miles away, but that's the way they put it. It missed Earth by 15 minutes. Nobody even knew it was coming, Earth, till it had come and gone. So, and we made every effort to get in touch with nations like Japan, Spain, Italy, England, France, to send somebody over here to testify with us, because it has to be a world thrust if we're going to really do anything about it. We can't pay the way, like we spent $34 billion on the heat of not what am I trying to say? Global warming. My president candidate couldn't think of the word energy. Global warming, spent $34 million on that and haven't done anything on it. But it looks like we're going to have world input to ever be anywhere near efficient on making the determination that all the people in the world ought to want. But we couldn't get any interest at all. And I think this chairman of this committee, that'd be a very good thing if he could have some hearings maybe in England, these other places, and get their interest up, because it's going to take money and take their working with us to make anything happen. I guess the only question I'd have is, Dr. Yeomans, whether you know of any private organizations that are involved in the near-Earth object detection, like Boeing or Lockheed or McDonnell Douglas or Texas Instruments, like to get them into it, but they can't do it themselves. So that's just something to think about. Do you have any suggestions on the private organizations and how they might work into it?
Well, Ed mentioned...
They said at one time a laser could affect them just a little bit, but it didn't say how much.
That's true. If you had a laser nearby, you could ablate the front side and introduce a thrust in the opposite direction. But in terms of the international cooperation, I couldn't agree more. In fact, the European Space Agency has been getting more and more interest in this near-Earth asteroid discussion recently. They're actually funding a so-called NEO-SHIELD program to look at various mitigation options, including kinetic impactors. There's an activity within UN COPIOS, the Committee on the Peaceful Uses of Outer Space, and NASA is involved with that working group to try and define an international warning system, not just the U.S., but international, and then work on the protocols that would be required in the event of a incoming object. Who would be in charge?
Dr. Liu suggested NASA. The reason I thought about Tiger Teague, Olin Teague, and all the work he did, and even getting it off the ground and supporting it with funds that we don't have today. And we can't go to Mars till people can go to the grocery store, so I don't know how we're going to talk about protecting the world if we don't have world support. Mm-hmm. And it'd be a great thing for this chairman, who, if the government doesn't have the money to send him, he has personal wealth that he could maybe take 4 or 5 of us over there. And I think he's going to tell me my time's over. I yield back what time I don't have.
Thank you, Mr. Hall. The gentlewoman from Connecticut, Ms. Esty, is recognized for her question.
Thank you very much. I wanted to follow up a little bit on, we've had discussion previously about this international issue, which Dr. Yu had mentioned. Can you explain to us what is currently done in terms of data sharing? And perhaps, Dr. Liu, if you could discuss if you've even contemplated now for your project, it not being a governmental project, being private, nonprofit, what you would contemplate being that data sharing aspect for your organization?
Our intention as a public nonprofit is to put the data out there so that as many scientists can see the data and use the data and warn people if there's things in the data that show that something's going to hit the Earth. So that is our plan. But actually, if I could add one other thing, don't get the impression that finding asteroids, while it is a lot of money, is something that requires enormous amounts of money. For instance, our telescope, which will find and track the great majority of these asteroids, is less than the cost of, there's a road widening project in the San Francisco Bay Area in the town of Burlingame that's more expensive than our telescope. And that's why we went about this as a private fundraising effort. We're less expensive than a museum. There's a wing of an art museum in San Francisco that costs more than our project. And that's privately raised money. It's not enormous. I mean, it's a lot for individuals, but it can be done.
If I can follow up, actually, that was very helpful because I did want to ask a little bit more. What are the specifics? What are your plans if you, obviously, we know that in the past NASA's encountered cost overruns for a variety of reasons. What are your plans as an organization if you discover, say, in the development or in the research phase that something that you anticipated will work does not quite work the way you expected? Would you go back to funders? What does that do? And also, frankly, how close are you to raising the $450 million that you have budgeted? Will you do it in tranches if you don't have it ready? What are your plans for ensuring that? Because we're hearing from everyone, if you don't have the money set at the outset, you end up embedding cost overruns because it just takes longer.
We are using existing technology to the extent we can, and we actually have a firm fixed price contract, which is, so in other words, the risk is borne by our contractor, Ball Aerospace. And yes, we are raising the money in tranches. This year our fundraising goal is $20 million. And we are well on our way towards that for this year.
And so how much of the total would that have you at?
Well, this really is our first full year since we've begun our fundraise. We announced on June 28th of last year. Our needs were quite small last year in the single-digit millions. This year they're accelerating, and next year they will accelerate even more. So our peak spending rate will be in the range of $100 million for a year or so, and then it will taper back down. But we can finance this over a much longer period.
And just a question for all of you somewhat. If we have congressional mandates that say previously would have been directed to NASA as a governmental organization, and Congress says we need to see this data because we need to make decisions, for the doctors who are not in the private entity, how would you contemplate would structure that, and how would that operate?
Well, I think it's important to point out that NASA does have a Space Act agreement with the Sentinel Group for providing navigation, tracking of their spacecraft, and the international component would be, once their data is taken, it would come through the NASA channels. It would go to the Minor Planet Center in Cambridge, Massachusetts, and then it would come to our program office at JPL, and then we would interact with our Italian colleagues, and it would go out to the world. So it's quite a transparent data sharing process, even though it's privately funded for the most part.
Yeah, I was just going to comment that in my experience, the data on finding and tracking near-Earth objects and on predicting the orbits of them all becomes very public very quickly. There's never been a problem getting the data. The only problems are what to do with it.
Thank you all very much.
Thank you, Ms. Esty. The gentleman from California, Mr. Rohrabacher, is recognized for his questions.
Thank you very much. I'll try to be as fast as I can here. First of all, I would like to note...
Mr. Rohrabacher, if you will suspend for a minute, I want to let the members know that after this series of questions, we are going to recess for about 45 minutes so we can go conduct 3 votes, and then we will resume the markup after the votes. The gentleman continues to be recognized.
Right. Thank you, Mr. Chairman. And number one, first of all, Mr. Chairman, I would like to agree with Chairman Hall and his recommendation that we work with you and both members of both sides of the aisle to try to find international cooperation on an effort that deserves to be not just the responsibility of the American taxpayers, but people of the Earth united against this common threat. Let me note there are other groups like the Planetary Society, headed up by Bill Ney, who are very involved with this issue, and I have a statement that I'd like to, of Mr. Ney that I'd like to put in the record at this point.
Without objection, so ordered.
Thank you very much. Next, I would mention there are 2 recently formed companies that have as their goal mining asteroids, the Planetary Resources, Deep Space Industries. Both of these companies have impressive teams, and I would hope that some future date we might be able to bring them to testify about their activities and the expertise that they're developing. Mr. Liu, I found your testimony to be very interesting. We have to assume that either road construction in San Francisco is incredibly expensive, or that we have in some way brought down the cost of your efforts, space efforts. I find, and it was your testimony, that B612 does not in any way receive any taxpayer funding?
That is correct.
Congratulations, Mr. Liu. I want to say that for the record. Congratulations. And I understand that the Sentinel mission under the foundation actually has been operating with fixed term prices that you are dealing with with the companies that you have to deal business with. Is that correct?
That is correct.
So you have a fixed price term. We have been told over again, Mr. Chairman, that we can't have these fixed price contracts. For example, with our polar weather satellites, you can't have a fixed price contract. Perhaps this private sector group here that doesn't receive any of our government money is showing us how we can keep some of the costs down. Let me just suggest that we need to get more private money, more international cooperation. This is a serious threat to not only to the well-being, but even perhaps to the survival of humankind on this planet. And it deserves us to work together and to do so in a cost-effective way. And we can't do anything nowadays unless it's in a cost-effective way. I'd like to thank you, Mr. Chairman, for holding this hearing, and I just will leave it at that, and appreciate your efforts, and I'm totally supportive.
Okay, thank you, Mr. Rohrabacher, and I know this subject has been of long time interest to you as well. As I say, we're going to recess for about 45 minutes, and then I hope members who still have questions will return, and if you all can possibly stay, that would be great. I understand one witness may have to leave, and if that's the case, we understand that as well. So thank you all, and we will return, and we will recess until about 45 minutes from now.
I want to thank the witnesses for staying behind for this important committee hearing, and at this time I'm going to recognize Ms. Bonamici for 5 minutes.
Thank you very much, Mr. Chairman. Thank you so much for your testimony, and thank you for staying. Sorry we had to leave to vote. I wanted to talk a little bit about how we respond. Dr. Ahern, in your prepared statement, you indicate the Academy's 2010 report provided options geared to how much money Congress wished to appropriate to buy insurance against an impact. And you described evacuation for small impactors as one approach to mitigation, and noted the panel's recommendation that a research program be instituted to better understand mitigation approaches. I represent a district in Oregon that contains coastline, and my constituents on the coast are frequently talking about being prepared, emergency preparedness for tsunamis and earthquakes. And so these are certainly analogous situations. In our prior hearing, NEO hearing, there was a discussion about evacuations in response to a meteor incident. So what would be the nature of the recommended research as it applies to evacuations? I know that when we're talking over in the Oregon coast now, they don't have a lot of time from the time they find out about a tsunami to get upland. So what do you see as the most cost-effective insurance, and can you talk a little bit about preparing for a meteor impact, please?
I think the most important issue is that we don't have a really solid theory of how big a tsunami you will get from a given size impactor. There are simulations that disagree by huge factors on how big a tsunami you will get at various places. So on that specific issue, I think that is the key thing that needs to be done. It depends on the size of the impactor, of course, depends on the velocity it comes in at, the speed, and it depends on the density. Is it really solid or is it mostly porous? But for any given case, even, there are disagreements in the theoretical literature on what the effect will be. So that is the biggest issue. once you know how big the tsunami will be, then you get a better feeling for how far you have to evacuate to get to high ground. And I am not familiar with how much time is needed in any specific area.
Sure, that's dependent, I think, on the geography. And to all the panel members, how should we approach the policy and legal issues in addressing warning the public? My constituents at home are worried about finding a job and about too many kids in a classroom. So, and on the coast, they're worried about a tsunami. And they went through, after the earthquake in Japan, some emergency preparedness, but there's still a lot to do. So what's the best way for us as policymakers to approach this warning and preparedness, and how should we handle that on national and international levels? What's your advice?
If I respond, there is an ongoing effort within the United Nations Committee on the Peaceful Uses of Outer Space to address these issues, and one of the key issues, as you noted, is how do we best warn the public, give them the facts without scaring them. So on the international level, within this committee, these discussions are ongoing, and that is one of the issues that is front and center. We don't have a process in place whereby, we're scientists, so we can say, well, we've got an impact probability of such and such, but that's not necessarily the most effective communication with the public. So we have to bring in folks who are more experienced in communications, not just scientists. So I would suggest that perhaps once these discussions are completed in hopefully another year, then some guidance for policy would come out of that.
Dr. Liu, do you have any input on?
Yeah, my opinion is that we should not find out what the impact of a large asteroid is in the ocean, and because we have the technology to prevent that. Mm-hmm. And we should go out there and find these asteroids, find out if any of them is going to hit us, and deflect it. And I think we can do that.
Thank you. And my time's about to expire. Thank you very much. Thank you, Mr. Chair.
I now recognize Mr. Posey for 5 minutes.
Thank you, Mr. Chairman. Somebody mentioned climate change study a little while ago. Asteroids took care of that at one time. And if it happens again, we will not have global warming. They can fix that for forever. Out of curiosity for the three of you, the administration is excited about privatizing space to the greatest extent possible. What do you think would be an appropriate number for an X Prize type of arrangement for identifying and destroying an asteroid? Just off the top of your head, all three of you, starting with Dr. Liu.
Well, if you ask the question, what would it take to find these asteroids first, for the first part of the X Prize? It's really a two-step process.
Right.
I would lay a number out that would be equivalent to whatever, some fraction of what NASA would have spent if they did it themselves. And that number is probably in the range, according to the NRC report, 800 million to $1 billion. Pick some fraction of that. That's why we think we can do it for $450 million, and that's what our contract specifies. But if you put the prize somewhere around there, then NASA is guaranteed to save money if it succeeds.
Yeah, and if it doesn't, the money is never spent.
Exactly.
Okay. How about that? That's the find one. Does that include destroying it?
No, but I think once you find them, remember that you will now know if there is something that's going to hit that's a definite threat in the next century, and now you've got time to do it right. And also, I think money is almost no object if something's really barreling down on the Earth and you know the time, date, and place that thing is going to hit. I think we can come together and solve that issue.
Okay, thank you. Dr. Yeomans?
I guess I would add that NASA already has 15 years of experience in this area of identifying objects, and they have 3 programs underway: ground-based optical detection. I would suggest perhaps a study that be undertaken to see whether we could leverage those assets to improve what is already there, bring new technology and new telescopes online. And there are also studies to flesh out what is the most effective way of deflecting an object that is found on an Earth-threatening trajectory. So I guess my comment would be we should leverage existing activities and facilities rather than, well, we should just leverage existing activities.
Okay, well, it's my understanding the Small Bodies Assessment Group at Lunar and Planetary Institute was chartered for the specific purpose of evaluating those types of missions and the priorities of the scientific community for near-Earth objects. How has NASA cooperated or leveraged its information with this group in planning of the asteroid capture mission?
I'm not intimately involved with the connection between the Small Bodies Assessment Group and this the mission that you mentioned. So I'm not aware of what has and what has not been communicated between those two.
Okay. Either of the others familiar with it, Dr. Aher?
I know essentially nothing more about this mission than I've read in the newspapers and in Administrator Bolden's release this morning. I am not aware that the Small Bodies Assessment Group has been given any information on it. They may have been, but I am not aware of it. So
well,
I'm not on that.
That was my feeling, and that's why the question. Dr. Liu?
I also am not aware of the connection between the two.
Okay. You know, all of your written testimony mentioned, obviously, the asteroid mitigation, and I know we have to identify them before we can divert them or destroy them. We all do that. But, you know, assuming that the development of a strategy and technology would take a considerable time, you know, obviously perhaps years, what steps do you think we should be taking in the meantime in case our search uncovers our threat, which we all know is not a matter of if, but when?
I think it would be prudent to do a deflection demonstration mission, pick an asteroid that you know is not anywhere near hitting the Earth, and show that you can deflect it in a controlled manner so that it doesn't break up into pieces where you don't know where they're going and so on. And I think that could be done.
Okay.
I would agree that a demonstration deflection mission is an appropriate thing to do, and a deflection mission is ideally suited for the international collaboration that I think is needed in this area, because typically you need to send two spacecraft, one of which does the deflection and the other of which monitors the effectiveness of it, depending on whether you're doing a gravity tractor or a kinetic impactor or we presumably would not do a nuclear one as a test. But and the ability to have international collaboration on coordinating two spacecraft is important to get the various countries trusting that we're not trying to divert something to land somewhere else.
Interesting. I hadn't thought about that, but I think you're correct. Dr. Yeomans, Mr. Chairman, can he finish?
Could I add something? There is an interesting concept pertinent to your point, whereby NASA would use the excess launch capability for the InSight spacecraft to Mars, have a co-launch of a impactor, much like the Deep Impact mission, and that would go and collide with the asteroid that the OSIRIS-REx mission has already picked for their target. So the OSIRIS-REx mission is already resident, and you've got this impactor coming in, and you can measure the deflection, and so it's a nice leveraging of an existing launch of an existing rendezvous spacecraft. So that would be one demonstration, deflection demonstration.
Very good. Thank you. Thank you, Mr. Chairman.
You're welcome. I now recognize Mr. Stewart for 5 minutes.
Thank you, Mr. Chairman. Gentlemen, thanks for being here. It gives me faith in our future knowing that there's people that are a lot smarter than me who are working on some of these things. I'm not going to ask real detailed. I'd like to kind of just encapsulate what I think we've said but bring some clarity to it before with some very quick questions. But before we do, can I just divert for just a second with this? And that is, you know, the old formula E equals MC2, and you've talked a lot about the mass of these meteorites, potential, you know, objects. But is velocity a consideration too? In other words, are some of these smaller ones, are they traveling at such a speed that they would have an equally devastating outcome, or are most of these objects kind of traveling at about the same speed out there?
Most of them are, well, they're orbiting the sun, and so the typical velocities that they hit is really independent of the size of the asteroid, and that's between 15 and, say, 25 kilometers per second.
Okay.
So 40,000 miles an hour or so.
So that's, I mean, that's a fairly good range. 15 to 25 is what, 40% or something like that. But the velocity doesn't really matter. It really is just the size and the weight of the object.
It's a combination of the destructive power is a combination of the speed and the mass. But from the standpoint of deflection, it doesn't much matter.
Okay. Yes, sir. Dr. Herring.
I was going to just add to that. Indeed, 15 to 25 kilometers per second is the right ballpark for the asteroids. It's one of the things you have to keep in mind, however, if you deal with the cometary impact hazard. Those come in at more like 30 to 70 kilometers per second. Now, they're very infrequent compared to the asteroids, but one of a given size will be much more damaging because of that high speed of entry compared to the asteroid.
Yeah. Okay, and I appreciated your visual that you showed us at the beginning. Kind of gives us a sense of the scope there. I know that there was a recent comet that was discovered in January that was looking like it was going to have a near miss with Mars, and it would have been a devastating event had that, you know, impacted the Earth, kind of a dinosaur killing type of event. And as I recall, it was 2 years is what the estimated impact time would be. Of course, we know it's going to miss it now. If that had been directed toward Earth in 2 years, is there realistically anything we could have done?
It would be very difficult.
Probably not. Is that true? Yeah. So can you give me an idea? I know you're speculating, but I mean, how much time do we need? Do we need 10 years? Do we need 20? Do we need 8? I mean, how long do we need before we could actually do something, even if we detected an object that was going to impact the Earth?
I think with 10 years, you can do this in a controlled manner with backups and so on. Certainly with 20 years, you could do that. It gets much more difficult the closer in it is, and that's again the importance of getting early warning, because the closer it in is to you, the more you need to deflect it by to get it to miss.
Yeah.
And so it gets much harder the earlier, the less warning you have.
Let's put that aside, that consideration of the energy to deflect it. In 2 years from now, are we technologically capable of launching something that could intercept it? Then, Dr. Herring, you seem to be shaking your head no.
No. If we had spacecraft plans on the books already, that would take a year. I mean, a typical small mission, like a Discovery class mission, takes 4 years from approval to start to launch. Okay, now a really accelerated military program would be faster than that, but that's a couple of years still.
Yeah.
And you would have to have something ready to launch, basically, if you wanted to do it on very short notice. 10 years, 20 years, then you've got time to plan it. 5 years or less, it's really hard. Unless you've thought the problem through and designed things, maybe have components built, maybe not a full system, but...
Because what we have nothing like this right now. We're not taking an existing weapon system or existing vehicle and modifying it. We're really starting from scratch to do this, true?
Well, you would try to use it from existing components. I mean, you would, if you were going to do a kinetic impact, you might scale up what was done for deep impact, larger launch vehicle, larger impactor, and things like that. So it's not quite starting from scratch, but it's starting from a pretty low point.
Yeah. Okay. And then, well, last question. Well, I tell you what, I'm out of time. I'd love to talk with you further, but appreciate you again, you being here. Thank you, Mr. Chairman. I yield back.
I I want to thank the witnesses for their valuable testimony and the members for their questions. The members of the committee may have additional questions for you, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments and written questions from members. The witnesses are excused, and this hearing is adjourned.